Hello guys, today we're going to talk about absolute value functions. We're going to be graphing them and talking about their domain and range. You've seen a little bit of these before. They're the graphs that look like V's, V shapes. First thing is right here. This is the parent function for an absolute value function. And we are going to use our ideas of shifting left, right, up, down to help us with graphing. So we're actually only going to make one XY table this whole lesson, and then the rest is going to be shifting. This is our function notation, f of x equals absolute value x. When you are given an equation in function notation and you want to graph it, it would be okay if you changed this f of x into a y. So really here's our equation, y equals the absolute value of x. And if I was going to make a xy table, I would probably want to pick some negative values, 0, and some positive values, just like we usually do. All right, and then we're going to plug in a -2. So the absolute value of -2 ends up equaling +2. The absolute value of -1 equals +1. The absolute value of 0 is 0. The absolute value of 1, remember, absolute value is a distance, and it's always positive. So it'll be a +1 again. The absolute value of 2 is a +2. Okay, graph those points. So -2, 2. Be right here, then -1, 1, then 0, 0, then 1, 1, and 2, 2. So what you'll notice is that we are going to connect them and they are going to look like a V shape. And the V goes on forever, so we have arrows like that indicating it's going to just keep going on forever. One thing I wanted to point out is that the number in front of the absolute value of x is technically a 1. I can do 1 times anything. And this is sort of like a slope. So if I have a slope of 1, that means I'm going up 1 over 1, up 1 over 1, up 1 over 1. And I'm doing that in both directions, up 1 over 1, up 1 over 1. So it's not technically slope because this is not a line, but it's kind of like I've got a line going this way and a line going that way. So I can sort of think of it as a slope. Which brings us to, this is our more involved equation. This is when we're going to involve our shifting left, right, up, down, and stuff like that. And I just wanted to point out that A is kind of like your slope. If A is positive, it's going to open up, and if A is negative, it's going to open down. The H value, that is your left or right shifting. And remember this, just like with any other function we've done, it's opposite of what you think. So if you have a positive value, it's actually going to the left. And if you have a negative, it's actually going to the right. So it's opposite of what you kind of think. And then the value of k on the outside of the function, that's your up or down shifting. And that is what you would imagine. Plus makes it go up and a minus makes it go down. So we're going to be using this idea for all of the rest of the problems because this is the parent function and everything is going to get shifted. This function will get shifted left or right, up or down. If the value of a is negative, that means it's going to flip and it's going to open down instead of up. And then the only other thing on this page I wanted to mention was domain and range. Yeah, maybe I'll keep it where it was. So the domain is the x values that we're allowed to have. We'll think about the xy table. I could plug in any value of x that I want. I could plug in a -10 and my value will be up here at 10. Or I could keep going. I could plug in a -20 and my value will be off the graph at +20. I can plug in any value of x I want. I can go to the right as well. So the domain is all real numbers. The range are the y values that we're allowed to have. If you look at your graph, there are no y values down here. There's nothing on the graph down here. The smallest y value is at 0, and then it goes up from there. So remember what I did when I showed you domain and range is I gave you like a little horizontal line. And when you do range, you start from the bottom and you go up. So there's no y values down here. Here's the smallest y value at 0, and then it goes above. And it can equal 0. So I'm going to say my range is y values that are greater than or equal to 0. So above 0. All right, so now we're just going to practice some more graphing. Again, this is that same general formula that I did on the last page. This is the parent function. I just have it dashed. And the idea is that we're going to practice shifting it and all that good stuff. So the first example here, the only thing that has changed is this number out in front, and that is the a value. And remember, that's sort of like our slope. So if I have a slope of 3, I could say that that is over 1. And remember how the top number is your y values up or down, and your bottom value is your x values left or right, rise over run, if you remember that at all. So this means I'm going to go up 3 and I'm going to go over in either direction. Actually, in this case, I'm going to go over 1. So this orange was the parent function. This is just, let me write this out. This is just a plain absolute value of x. Nothing else fancy about it. But if I change this now to a 3, I would start here at the same point at 0, 0, but now I'm going to go up 1, 2, 3 over 1 in both directions. So up 3 over 1 over to the right and over to the left. And then from here, I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. And then this one, I'm going to go up 3 over 1, up 3 over 1. So here's the center point. I'm going up to the right, up to the right, up to the right. And then starting back from the center point, I'm going up to the left, up to the left, up to the left, so that you get that V shape. All of these should look like V shapes, perfect V shapes. Okay, so if I connect those dots and I put my arrows on the ends, this is 3 times the absolute value of x. So that was this pink graph here. So it got skinnier and taller. Okay, then we're going to do, I'll do light blue. We'll do this one right here. Okay, now this is the value of a. And you'll notice that it is a negative value. So that means we're going to be going down 2 and then either direction 3. So I would start at 0, 0, just like all the other ones did. But now I'm going to go down 2 over 3, down 2 over 1, 2, 3, down 2, 1, 2, 3. But I'm going to do the same going in the other direction. So I'm going to go down 2, but now I'm going to go to the left 3. Down 2 to the left 3. Down 2, 1, 2, 3. Okay. So, and then I'm going to connect that with some nice lines. And I'm going to put my arrows on the end because these go on forever in both directions. Okay, so if you have a negative right there, that's going to essentially take this orange graph and flip it down. So now it's opening down. Okay, so that's all we did was practice changing this A value. That's all we did in these examples. Now we're going to practice changing the H value. So this is when we've got something inside the absolute value. If we go back to our first page, that H value inside the absolute value, that's in charge of shifting left or right. Okay, so which way do you think this is going to go? Left or right? When you see a minus, it's actually going to the right. Remember, when it's inside the function, it's like the opposite of what your intuition would say. And then I just wanted to show you this parent function here. Essentially what I'm doing is I'm just going to pick up that graph and I'm going to shift it to the left or to the right. Okay, so for that first problem, I'm just going to shift all of the points to the right 4, and my graph will look like that. But I'm going to keep that parent function there just as a reference. Okay, so again, this was just the absolute value of x. Now what we're going to do is we're going to shift all of those points to the right 4. So this is going to go to the right 4. There was a dot here at 1, 1. That's going to get shifted to the right 4. There was a dot here at 2, 2. That's going to get shifted to the right 4, etc. And then this point right here, which was at negative 1, 1, that's going to go to the right 4. 1, 2, 3, 4. This point that was at negative 2, 2, that's going to go to the right 4. This point that was at negative 3, 3, that's going to go to the right 4. Okay, and then that point is going to get shifted to the right 4. All of them get shifted to the right 4. And then we're going to connect our dots and make a V shape. Oops, I have to move that one a little bit if I can. That's better. And then always put arrows on the ends. Okay, so this was x minus 4 inside the absolute value. So it shifted to the right 4. Okay, this graph, we've got a plus 6 inside the absolute value. So that is going to be a shift to the left 6. Remember, it's opposite of what your intuition says. So plus is actually to the left. So this orange parent function is going to get shifted 6 to the left. So this point here that was at 0, 0 will now be right here. Shifting this point to the left 6 will bring you here. This point shifted to the left 6. This point shifted to the left 6. This one shifted to the left 6. And then all of these over here on this part of the V shape are also going to get shifted to the left 6. So this is going to go 1, 2, 3, 4, 5, 6 right here. And this one gets shifted to the left 6. And that one goes to the left 6, etc. All right, so then I'm going to connect my dots. And put arrows on the ends. Okay, so just wanted to show you, hopefully, maybe see if I can get this to work here. Oh, maybe not. I just want this orange one. Oh. Okay, so I got it now. So this orange parent function, if I shift it to the right 4, do you see how it lines up? And if I shift it from here, if I shift to the left 6, it lines up. So that's all we were doing, was just shifting that parent function to the right or to the left. That's when it's inside the absolute value. Okay, you might want to write yourself a little note like this: inside the absolute value goes to the left or to the right. Okay. Then we're going to practice what happens when you are adding or subtracting something outside of the absolute value. That, when it's outside of the absolute value, that's your shift up or down. And that is what you would imagine. So when you see a +3 on the outside of the absolute value, that +3 is going to make it move up 3. So I would just take all of these values and I would shift them up 3. So this dot right here goes up 3, this dot goes up 3, this dot goes up 3. All of them do. This one over here goes up 3. Okay, so we're just taking the parent function and we're shifting it. This was the parent function, absolute value of x. We just shifted all of those points up 3. I'm going to connect my dots, put my arrows on the ends, and this is the function, the absolute value of x plus 3. And then this one right here, you are subtracting 8 on the outside of the absolute value, so that is a shift down 8. So I'm going to go back to the original, the orange, and shift all of those to down 8. So all of these get shifted down 8. Okay, that's probably good enough. And then I'm going to connect my dots. Put arrows at the ends. And this was the absolute value of x minus 8. It went down. Okay, so that's just your shifting up and down. I forgot to write the equation for this one over here, so I'll just add that in. This was on the previous page. Okay, just to make it thorough and nice. All right, so now we're going to kind of put it all together. So in this example, we've got a value of a out in front here, so that is like our slope. So if we have a slope of 1/2, that means we're going to go up 1 and then go over 2 in both directions. And then this minus 3 means that we're going to shift to the right. It's inside the absolute value, so that's your shift left or right, opposite of what you think. So when you see a minus, it's actually to the right. And then when it's outside of the absolute value, that's your shift up or down. And since it's a minus, it's going to go down. Now, the shifting right and down, that would be a good place to start. So normally we would start at 0, 0, but this is going to get shifted 3 to the right and down 4. So that's where I would start. So we went 3 to the right and we went down 4. That's where I'm starting. And then I'm going to use my slope from there. Okay, so we're going to go up 1 and then over 2. So from here, go up 1, over 2, up 1, over 2, up 1, over 2. Go back to that starting point at 3, -4, and then we're going to go up 1 the other way 2. Up 1 to the left 2. Up 1 to the left 2. And that's probably enough points. And then you're going to connect it. Make it look like a V. And I could have continued that longer. I wonder if it'll let me do it. Yeah. Okay. And then I'm going to put my arrows at the ends. Okay. Now, I'm hoping that this kind of looks familiar to you. When we did quadratics, U-shapes, and we had them in vertex form, it was very similar to this. Vertex form looked like A, and then it was X minus H squared plus k. That's when we were graphing U shapes. And do you remember how the vertex for those, when they were in vertex form, the vertex was h comma k? It's the same exact idea here, except we don't have a squared, now we have an absolute value. The vertex is the same kind of idea where you do the opposite of what you see inside here. So I see a -3, I'm going to write a +3. And then whatever's outside stays the same, -4. That's where you want to start. Start at the vertex and then use your slope. Now for domain. Domain are all your x values. So x is looking left and right. This arrow is going to go on forever to the left, and this arrow is going to go on forever to the right. So it can be anything. It can be all real numbers. But the range are your y values, and there's no y values down here at all. So looking from bottom to top, the smallest y value is here at -4, and then all these y values are above it. So it can equal -4, and then it's everything above -4. So that would be greater than or equal to -4. Again, let's see if I can borrow this horizontal line from a couple pages ago. Maybe not, we'll see. Okay. All right, so again with range, we're looking from bottom to top, okay? And there's no y values down here. The smallest y value is right there at -4, and then it's all of these above it. So greater than or equal to -4 is the range. All right, so just as a reminder, I hope that you wrote this down. Start at the vertex. So the opposite of what you see inside. So I see a -3, I'm going to write the opposite, which is +3. Keep this number on the outside the same, -4. That's where we started. We started here at 3, -4. And then you use your slope, up 1 over 2, up 1 over 2, up 1 this way 2, up 1 this way 2, to get your V shape. So let's practice that one more time here. So my vertex, that would be a good place to start. The vertex is, look inside here and write down the opposite of what you see. So a -4 would be the opposite. Keep this number the same, 7. So -4, 7, that's our starting point. Okay, and then this value of -2, that's like our slope. So if I have a slope of -2, I could write that over 1. And that means I'm going to be going down 2 and then left and right 1 over 1. So from the starting point, the vertex, go down 1, 2, and then over 1. Down 2, over 1, down 2, over 1. I could keep going. Go back to the starting point, go down 2, and the other direction 1. So now down 2 to the left 1, down 2 to the left 1. Okay, and then connect those dots. Put arrows on the ends. Okay, and just as like a little reminder, remember how this +4 would have made it shift to the left 4, and this +7 would have made it shift up 7. So normally we would start at 0, 0, but we went to the left 4 and we went up 7. That's where our vertex is. And then the slope is how we move to get the rest of our lines. Domain. What x values are we allowed to have? Well, this is going to continue to go off to the left forever, and this is going to continue to go off to the right forever. So I can put in any value of x I want, all real numbers for the domain. For the range, those are the y values we're allowed to have. Okay, now let me grab that horizontal line again. So these arrows would continue down. So I would have, let me see here. Just trying to make this pretty. I did not continue my graph, but I could have kept continuing. So this would keep going on forever down here. This would keep going forever like that. Okay, so I have y values way down here. All of these y values are totally cool until I get up to 7, and then there's nothing above 7. So one way of saying that is my y values have to be 7 or below. 7 or below. Another way of writing that would be less than or equal to 7. It can equal 7 up here, but then it's all the y values below it. Okay, so just as a little recap, if you have a value on the outside here, that's your shift up or down. If you have a value on the inside of the absolute value, that's your shift left or right. A is like your slope. Okay. And then it's all based on this parent function here. And so we're just taking that and we're shifting it. If the value of A is negative, it's going to open down, just like we saw here with the blue. When this value of A was negative, it opens down. Let's see what else. And then when you have problems like this where it's pretty involved, I would find the vertex, and then from the vertex, move according to your slope. All right, that'll do it for today. Have a good one.